Welcome to r/Payback, where the pressure test that exploded a career and saved a plant. A couple years back, I worked as a mechanical technician at a gas bottling plant. It wasn't a glamorous job, but it paid well, and it came with a heavy dose of responsibility. My team's main role was pressure testing high-pressure gas canisters before they were shipped out to clients, mostly medical facilities and industrial clients who needed large volumes of compressed gases. When I say high pressure, I mean these things held thousands of pounds per square inch. One weak weld or hairline crack could turn a tank into a missile. We had strict protocols and test chambers built like bank vaults for a reason. If a tank failed during use or transit, it could easily take out a wall, or worse, a life. Our department was small but tight-knit. We all knew the stakes. Nobody cut corners, and every test was run by the book. That was non-negotiable. And until this particular week, management had mostly left us alone to do our jobs safely and correctly. But then, a new shipment arrived, and with it, a string of bad decisions that would, quite literally, blow up in our faces. It started on a Monday morning. I came in, grabbed my coffee, and headed down to the receiving bay where we offload new shipments of canisters for inspection. The moment I saw the stack of tanks being unloaded, my stomach turned a bit. They were from a new supplier. I'd never seen their name on our intake logs before, and these canisters didn't look like the ones we usually worked with. For starters, the exterior surface looked off. Several tanks had small dents and abrasions, and one even had a faint gouge running lengthwise along the seam. I got closer and noticed the weld lines were sloppier than usual, uneven beads, some spatter left uncleaned. Worse, a few of the valves weren't aligned properly. One had a crooked stem that made it hard to even screw on a cap. These weren't cosmetic issues. These were failure points on a tank designed to hold 3,000 psi of compressed gas. I went through my inspection checklist, marked the tanks accordingly, and took some photos. These tanks shouldn't have passed even a preliminary visual check, let alone be approved for testing. That sinking feeling in my gut grew stronger. Something didn't feel right about this batch, like it was rushed, or maybe even counterfeit. And given what we were dealing with, I knew this wasn't something I could brush aside. I brought my findings straight to my immediate supervisor, Dave. Dave was one of the good ones, an old-school guy who had been in the industry for over 2 decades. He took one look at the photos and said, "Yeah, this isn't right. Let's bring this up the chain." Together, we walked the floor to the plant manager's office. That's where things started going downhill. Our plant manager, Carl, was a corporate guy. No engineering background, no technical certifications. He came from logistics, or marketing, I forget which, and had only been in the role for about 6 months. What he did have was a laser focus on shipping quotas and bonus incentives. Safety was something he trusted the team to handle, as long as it didn't affect the delivery schedule. We laid everything out. The visual defects, the questionable welds, the potential safety risks. We explained that these tanks needed to be rejected and sent back to the supplier. Dave even pulled up a past incident from another facility where a similar defect had led to a serious failure during transport. Carl didn't care. He glanced at the supplier paperwork and said, "They signed off on the specs. That's all that matters. Just get them tested and cleared. We're already behind schedule as it is." I tried to push back. I reminded him that we were dealing with explosive pressure levels, not soda cans. He cut me off. "Look, if something's wrong with them, the pressure test will catch it. That's what the test is for, right?" I couldn't believe what I was hearing. But fine. You want to rely on the test to find the flaw? Let's really find it then. Carl's arrogance made one thing very clear to me. If this went sideways, he was absolutely going to throw someone under the bus. Probably me. So I made sure every step from that point forward was documented down to the second. I snapped high-res photos of the visibly defective canisters, highlighting weld inconsistencies, valve misalignments, and surface damage. I logged my observations in the intake system with detailed notes. I forwarded my full written report to my supervisor, CCing Carl, and explicitly recommended the batch be rejected. Carl responded in writing, "Proceed with testing. If they fail, we'll address it then. Perfect." That email went straight into a backed-up folder and printed out for good measure. The next morning, I prepared the pressure test chamber. It's a reinforced steel booth with blast-resistant walls and a remote control system for a reason. Things can go very wrong, very fast. I double-checked all seals, the control software, the high-speed camera feed, everything. Then I selected the worst canister of the bunch, the one with the crooked valve and the ugly weld seam running the length of its body. If any of them were going to fail, it was this one. I loaded it into the chamber, locked the doors, and activated the remote test panel from the control room. No shortcuts, no improvising, just strict, by-the-book, malicious compliance. Let's see if the pressure test catches anything, shall we? The test began quietly. I watched through the thick glass of the control room as the canister inside the chamber started filling. Compressed air hissed through the supply lines. The gauges ticked upward in steady increments. 1,000 psi, 1,500, 2,000. So far, everything looked stable, at least visually, but I was watching the weld seam, that ugly, uneven line of metal that had clearly been rushed. 2,500 psi. A faint creak echoed through the chamber. Not unusual, but it caught my attention. I glanced at the structural stress monitor, which was starting to flicker into the yellow zone. Not critical. Not yet. 2,700, 2,800 psi. And then, it happened. With a sound like a gunshot, the canister snapped. The weld seam tore open with a violent crack, and the next second was chaos. A shockwave blasted out inside the chamber. The explosion was so powerful that the steel test sled ripped free from its bolts. One of the high-speed cameras shattered. The chamber door, reinforced and bolted, buckled outward, but held, barely. The entire floor shook. 2 alarms went off. Emergency lighting flickered to life. In the control room, we instinctively ducked, even though we were behind several inches of reinforced glass. Through the haze of the internal camera feed, I could see twisted metal, gas venting, and shards of the canister embedded in the test booth walls like shrapnel. Luckily, nobody was hurt. The chamber did its job, but the damage was undeniable. We had just experienced a full-blown catastrophic failure, and it happened exactly where I said it would. The test floor was immediately shut down. Maintenance teams were called. Word spread fast, and before the dust even settled, management and safety were already storming the site. The emergency protocol kicked in immediately. Red strobe lights flashed as security cordoned off the area, and the safety officer arrived within minutes, followed shortly by upper management and an external auditor from our corporate compliance team. Carl showed up red-faced and clearly rattled. He barked at maintenance, asked pointless questions, and tried to look like he was in control. Meanwhile, I calmly printed out the pressure test logs, camera recordings, and the chain of emails that led us here. Within hours, an official investigation was launched. The damaged chamber was inspected, the failed canister removed and photographed. Every employee involved, including me, Dave, and Carl, was interviewed separately. When it was my turn, I handed over the full file. My intake report. The defect photos. Carl's email instructing us to proceed. Time-stamped notes from the test. Footage of the exact moment the canister exploded. The investigator barely asked me any questions after that. It was all there, plain as day. Carl, however, tried to pivot. He claimed the failure was due to improper handling during setup, and that maybe I had selected the wrong tank or made an error in the pressure curve settings. Too bad for him, we had redundant logs that confirmed everything had been followed, step by step. And even worse, Carl was caught flat-footed when the external auditor asked, "Can you show us your written approval for this batch?" He didn't have any, because the only thing he ever wrote was that single dismissive line, "Proceed with testing. If they fail, we'll address it." Well, we failed. Spectacularly. And now he had to address it. The fallout from the explosion was swift and far-reaching. The supplier? Blacklisted within days. Every single batch they had ever shipped was pulled for inspection, and multiple high-priority projects across the country faced delays. Their reputation crumbled as word spread about their shoddy workmanship. Contracts were voided, and they quickly found themselves on the receiving end of legal action. All their financial backing dried up faster than a punctured gas line. As for Carl, he didn't fare any better. Within a week, he was reassigned to a different, lower-profile project, one where his utter lack of technical knowledge and decision-making couldn't do more damage. But it wasn't long before that assignment ended, too. Quietly, without ceremony, Carl was let go. It wasn't a public firing. No dramatic exit or announcement, just a swift internal process. The company didn't want to draw attention to the fact that an unqualified project manager had overseen a failure that could have had deadly consequences. But internally, everyone knew the score. The financial losses were staggering. The plant had to undergo weeks of unplanned downtime for repairs and system checks. The damage to the test chamber alone ran into the six-figure range, and every delay cost the company a fortune. Work on the line came to a screeching halt, and the promised completion dates for our clients were pushed back several months. As for me, I was cleared of any wrongdoing in the investigation. The documentation I had carefully maintained throughout the process became a key part of proving my thoroughness. I was praised for my attention to detail and commitment to safety, both by upper management and the external auditors who were sent in to review the incident. While Carl tried to deflect blame, my meticulous records left no room for doubt, and the company's leadership made sure they noted it. It wasn't just about the explosion, it was about how I had protected the team, the company, and ultimately, the lives of those involved by sticking to the rules and protocols, no matter the pressure. A month later, I was promoted to a higher role within the company, one focused on safety oversight and quality assurance for high-risk projects. It was a natural progression for me, given the events that had unfolded, but it also felt like an ironic twist. Here I was, being rewarded for my compliance with the rules when, in reality, it was that very compliance that had caused the explosion in the first place. It made me think long and hard about the importance of principles. Sometimes doing things by the book can feel like a hassle. It's easier to let a few things slide or bend the rules in the name of getting the job done faster. But after everything that happened, I realized how crucial it was to follow procedures. Sure, Carl's lack of technical knowledge might have allowed him to push through risky decisions, but it was my dedication to safety, even in the face of pressure, that saved the day. Not just for me, but for everyone involved. The company's systems were intact, and no one was injured. I also understood that malicious compliance wasn't just about following orders when it didn't make sense. It was about making sure you protected yourself and protected the bigger picture. If I had ignored the problems and blindly followed Carl's instructions, who knows how much worse things could have been. In the end, it wasn't just my career that was saved that day. It was the entire team's safety. The moral of this story is simple but crucial. Always document everything, and always follow protocol, even if it feels like you're being unreasonable or inconvenient. When you're asked to ignore safety, Whether it's in the name of deadlines, convenience, or a boss who doesn't get it, maliciously comply. Follow every rule, keep track of every detail, and protect yourself with documentation. Don't take shortcuts, don't bend the rules, and don't let anyone push you into compromising on safety. In my case, following the rules didn't just protect me, it protected the entire company. While Carl focused on pushing forward, I focused on making sure that every step was done by the book. And when things went wrong, that documentation became my shield. I was able to prove that I had raised concerns, had done everything possible to follow the process, and had no part in the failure that happened. The explosion was inevitable. But the consequences could have been much worse if I hadn't documented everything and complied fully with every step of the procedure. The explosion didn't just happen by chance. It was a chain of events that could have been avoided if only the right protocols had been followed from the start. But in the end, the moral of the story is clear. Never let the pressure of deadlines or a poor decision-maker cloud your commitment to safety and procedure. Malicious compliance can save more than just your job. It can save lives. That wraps up today's episode of r/Payback. If you enjoyed the ride, don't forget to subscribe for more epic stories.